Okay. For those of you online, I do apologize that trying to show that full screen really just bugged out my computer just now. So we're just gonna watch it not full screen. Hopefully it will play.
О, смотри, этот вертолет, значит, точно уже что-то пришло.
So that's a river fire that was caused by a broken pipe. So there's some sort of petroleum gas. I guess it would have been probably oil, not gas, but an oil pipeline going under this river burst apparently, and then caught fire. And so that's what it would look like, just as an example. So pretty intense, pretty scary, pretty fierce. What's that? Probably so. Yeah. It's such a sort of a shocking sight that I show it a lot, just because it's intense. Okay, links here for that article. I have them posted to Moodle as well. Okay, so other types of pollutants that we care about would be, first of all, toxics is another class. So we have conventional, talked about toxics being heavy metals and any kind of organic molecules that are particularly toxic to, and this could be humans or wildlife or plants, flora and fauna. Then we have non-conventional, which is a catch-all again for everything else, which would include nutrients. So even though these other macronutrients like ammonia, or basically nitrogen forms, right? It could be ammonia, it could be nitrate, nitrite, phosphorus. Maybe you don't have too much BOD discharged, but you are discharging a bunch of phosphorus, let's say. Well, that could trigger algae blooms, or it could provide that last nutrient that was lacking for a natural system to go crazy with biological activity and consume the BOD that was already there. The bacteria didn't have the right nutrients in order to make use of it. So if we think about agricultural impacts, this is a big challenge, because essentially what agriculture is doing is saying, hey, we want our plants to have plenty of these things. And really, it would benefit any plant growing operation to avoid any waste of this. But the reality is there's going to be a runoff, right? And so we've actually excluded from our natural waters list, we'll talk about in a minute, agricultural irrigation ditches, because they're never going to be able to meet these standards that we have for our nutrients, simply because we are using fertilizers, right? We fertilize the crops so that we can grow food, and to say no, like they've been trying to do in the Netherlands a bit, to stop using so much fertilizer. Well, what happens is then you don't have food, right? And that's not ethical. That's not tenable. So there's a big challenge there. We understand that there's a big environmental impact here, and perhaps we can continue developing smarter, better ways to farm that'll save money and save on wasted nutrients. Obviously desirable, but not obvious that you can just say stop doing it and that's okay, right? So that's one of the things that we have to balance here is as the situation with this national pollutant discharge elimination system quickly showed, you can't actually eliminate everything, and it doesn't make sense to eliminate everything. The clothing dye manufacturers, right, if they can treat their water to the point where they've removed, let's say, 99.9% of the dye, and it's not toxic or whatever, that 0.1% they could discharge. It's a pollutant. They're discharging a pollutant. But if it's having zero environmental impact that's discernible, measurable, that's probably a good thing in the sense that they are capable of producing the clothing, right? It's probably something we actually want, is for them to have that ability, so long as we're also protecting stuff. Okay, so Real quick, I'm going to give you a couple of things about the primary treatment before we get into the permit writer's booklet thing, and to talk a little more about the permit writing in particular. The primary treatment, I just want to go ahead and get this out of the way. We don't really need to spend much time on primary treatment generally, in part because it's so simple, right? So I'm just going to take 5 minutes to do that. And then next time, well, first of all, we've already done sedimentation, right? So we already have done a lot of the primary treatment, technical aspects. In terms of the screening, bar rack, and that sort of stuff, show you a little example here. And then I also want to note that the sewer collection system, just like the water distribution systems are part of the treatment in a sense, the sewer collection is also, in a sense, part of the treatment, part of the wastewater treatment. And so I have an entertaining video here for you. You know what? Before I do that, I think I should probably not log into. I think my wife was logged into Facebook there, so I'm gonna not do that. Don't think it matters. Okay, so hopefully this time it won't kill the screen when I try to do this. Okay, and I want sound. Oops. One moment, sorry. Okay, so this should hopefully give you a little new perspective on sewer collection systems.
So-called flushable wipes getting stuck in the sewer systems.
I have never seen one dissolved.
They have to remove them on a daily basis.
Okay, and that picture sort of sums it up, right? Don't flush flushable wipes. They're not actually flushable, right? That's the takeaway for primary treatment here. Okay, so yeah, that is potentially kind of gross, right? Perhaps a little bit shocking. And to be quite honest, let me full screen this again. I got a chance to tour the Detroit wastewater treatment plant while I was working at MDEQ, which is a really, really large treatment plant. And I will say that there was debris, like the stuff that he was just mentioning, kind of everywhere. There were wipes. You just walk around. I mean, different parts based on the different operations. Is it dealing with the grit chamber, grit removal chamber? There's like a whole room full of things like what I'll show you next, just to kind of walk through and navigate through all the junk. And even in other places in the system, this is just going to be some advertisement here for their particular system or whatever. But they had some sort of automated system. There's just like garbage that had been flushed everywhere, right? Just nasty stuff. And so you could see it like different parts of the wastewater treatment plant. The Detroit system was quite, they handle more wastewater than I think any other single treatment plant in the country. And it showed because it wasn't particularly, clean. I think they have some room to grow to even despite the fact that they handle so much. So you could have a typical system that's like this. It's gathering junk, and then you have an automated removal system. There's all sorts of ways you can imagine you could engineer a system to catch particulates, debris out of a system, and automate the collection, or at least scoot it all off into one spot or something where you can manually do so. So that things like this are very common. You see this one in particular is just continuing, showing you how it's operating and all that, and then ultimately that's collected into some sort of a garbage bin, right? So pretty typical there. Not much to speak of, but that's sort of the other part of primary treatment. Screens, bar rack, grit chambers. Now, grit chambers, I guess, may be a little bit interesting. I don't have an example for you, but sometimes they'll have like this rolling barrel that has a bunch of holes in it, and as the water's flowing through, it'll catch the small grit. Yeah, push it.
This summer, I had when I was working, we had a company come and show us some of the submersible pump that would chop stuff up.
Yeah.
And they would throw a Barbie doll in there, catch all this stuff. Is that mostly just for when stuff reaches the treatment plant, or is it still a problem within the regular system, in the water lines?
Yeah. Okay. So that's very interesting. A good question. I'm going to repeat it a little bit here. So, someone was saying that in an internship, right?
Mm-hmm.
You had a company come in and advertise about a submersible pump that was also sort of a shredder. So it's almost like a garbage disposal sort of system that would even shred up Barbie dolls or things, right? You could have that at a wastewater treatment plant at the intake of it, and that's I think what they were probably proposing it for. But yeah, you're right. That doesn't help in the sewer system itself unless everybody who might be accidentally flushing a Barbie doll or whatever, Legos, something down the toilet, unless they had one at their home, which they're not going to. Yeah, so there's still a problem of the sewer system itself, what we call collection system. Now, some places, like Baton Rouge in particular, or other areas that are very flat, can't make use of gravity-fed collection very well. Most places use gravity as much as they can, and so a lot of the sewer flow is just going to be based on the gravity elevation changes. When we don't have much elevation change whatsoever, like here, we have a lot of pumping stations. So you'll go around probably in the neighborhoods. There's one just off campus. You'll see this little facility of some sort, has some sort of gate, and they'll have a little tag saying PS 499 or something. And so you'll end up seeing them kind of everywhere here if you think about it, and if you're looking for it. And those are pumping stations to move stuff along, and they might have or probably have some design to handle some breakup of stuff, because if one of these fatbergs becomes sort of mineral deposit-like thing, that could really tear up a pump, right? So they're probably going to have some protection for it and some design that it could handle the chopping up some of the stuff. So yeah, that's a great question, and another important part of wastewater collection itself. Okay, so I wanted to tell you a little bit about this experience I had with a permit writers course. So one of the reasons I decided to I'd take a shot at coming back to academia was my experience at DEQ in this. Now, part of the problem was I had just finished an advanced degree, and then the job that I was able to land in Michigan, I had to stay in Michigan because my wife had a spot there, position there. was an entry-level permit writing job. So it was nothing fancy. I was, when I went back and started doing a postdoc, I had a pay raise to do that, and postdocs are not super well paid. So it was not particularly rewarding or making good use of my talents. I really just kind of wanted to use a calculator one day at work at some point, and I just never had any opportunities to use any of my skills. So that said, I did end up going to a week-long course, which was entertaining in some manner. And I have this booklet. I posted it to Moodle. That's the other thing I was going to show you. So on Moodle, I wanted to let you know that I have now opened up the Flint water crisis materials. I meant to do that before, but posted the slides we went over. I'm linking to Mark Edwards, that Virginia Tech professor, a lecture he gave on the whole matter. It's very interesting, a very different perspective than what I was able to give. Then a couple of papers from his group that are quite insightful and useful, I think. Then here in this wastewater, here's this permit writer's workbook. This was their 2015 version, so perhaps there's been a few updates since then. The one thing that was kind of interesting or humorous was essentially this workshop was about 8 hours a day of mostly monotone talking about different wastewater regulations and just really put you to sleep because and then it was also the Midwestern accent, and then all the different lakes and rivers, and it's like Menominee, blah 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 blah. It's just, I don't know. It's just kind of a funny, strange experience, and you know, it was a little bit telling about how long I was going to stay there. Okay, so but this the workbook itself was pretty interesting. I think there's a lot of neat stuff I can show you here, worth going through the first couple modules. So this book, and we didn't make it through all of it, but we made it through a lot of it. What I'm going to show you is kind of the overview of the Clean Water Act, and then probably skim through a little bit of this second module, scope and regulatory framework for the NPDES program. If you're curious about the nitty-gritty of these things, and there are certainly interesting jobs within this program out there, whether that be on the enforcement, whether that be on the permit writing when you get to more advanced, whether that be in industry, making sure you're handling these. This stuff is quite relevant in general. So not meaning to say that it's all boring and irrelevant. It's just my job there happened to be boring and felt irrelevant. Okay, so Clean Water Act, mentioned briefly that really is very early on. It was the Rivers and Harbors Act, eventually evolved into the Clean Waters Act, or kind of was the foundational point that we built on. So 1899, we had the Rivers and Harbors Act for navigation. 1948, we started to realize we had some pollution issues. So that was the Federal Water Pollution Control Act. Understandably so, with all the industrialization happening. We really started to put in human concerns there. 1965 was the Water Quality Act, which required standards for interstate waters, so any water that crossed between different states. I think one of the early issues was like, hey, all you states upstream of us, where do you get, like, how are you allowed to mess up our water that we need to use here? And there's some legal disputes there that I think probably some of the early stuff. Okay, so a couple of quotes from that Cuyahoga River here. It said, some river, chocolatey brown, oily, bubbling with subsurface gases. It oozes rather than flows. Anyone who falls into it does not drown. Cleveland citizens joke grimly. He decays. The Federal Water Pollution Control Administration dryly notes, the lower Cuyahoga has no visible signs of life. Not even low forms, such as leeches and sludge worms that usually thrive on wastes. It is also literally a fire hazard. Okay, so in 1970 then, we get the EPA and this Refuse Act Permit Program, or APP. That was an executive order in 1970. Ultimately, that was struck down, and Congress was told to fashion something from a legal perspective. And whatever your views on politics are, it might this might be an interesting example of how things tend to work, and maybe it's a good thing, even if frustrating, that an executive order can start something perhaps, or start a direction for something. If it's then not actually legal in a constitutional manner, then the courts should strike it down. But then perhaps that gives a good foundation for our legislators to proceed and to develop something that is more appropriate. And so, I don't think I have any opinions about all this, but that's sort of what happened there. And so in 1972, we got the Federal Water Pollution Control Act. So kind of amending those things and putting forth something that was legally tenable or constitutional or whatnot. So that kind of was the core of what we have today. Later added the Clean Water Act in 1977 and the Water Quality Act in 1987. Those would kind of first start prioritizing pollutants and effluent guidelines in 1977, and then in 87, those water quality-based effluent limits, and adding the stormwater control. Okay, so those were the two things that were added then. Okay. So, 1972, the objective there for the Water Pollution Control Act is to restore and maintain the chemical, physical, and biological integrity of the nation's waters. And if you think about that, restore and maintain, so restore them to, I guess, a non-impacted state would be the goal there, and then maintain that so that they could sustain the typical activities you would expect from a natural system. National goals and policies included at the time to eliminate the discharge of pollutants to navigable waters by 1985. So just eliminate all pollution. No more pollution. So you can see here that perhaps was a bit naive. I think that we realized later. And then they had an interim goal to achieve by July 1st, 1983, wherever possible or wherever attainable, a level of water quality that provides for the protection and propagation of fish, shellfish, and wildlife, and provides for recreation in and on the water. So that's essentially the intended use, right? That's the clause that really gets to it. And what we find is that interim goal is probably actually the best goal, because elimination of discharge is probably not actually beneficial for society, in the sense that there are too many important uses for water that we simply would not be able to, like, if I were to tell you, okay, we're not allowed to have a wastewater treatment plant anymore. Good luck today finding an appropriate place to use the restroom, right? Where it's not going to contaminate the environment. Just that alone, right? It kind of tells you something, right? Or, okay, now we need to apply reverse osmosis to our wastewater and do all of these steps to make it absolutely pure. Then we should probably study the receiving water and make sure we match exactly the contaminations that are already there. That doesn't make sense either, right? None of that is like, because if you discharge something that's different than the receiving water, you're polluting. If you discharge absolutely pristine, pure water, and your temperature is different, that temperature is a pollutant potentially. If then you make it not as saline, you just polluted the water, right? That's not really a tenable goal there. So this interim goal has essentially become what we now use as our standard or our priority goals. And that's, by the way, it says wherever attainable. We have not attained that everywhere. Caveat being, some places the water, let's say you have a very pristine, untouched, no human impact bayou somewhere in Louisiana, probably does not meet some of the fecal coliform guidelines, right? It's just the nature of it. So sometimes there's not going to be the right conditions accordingly, but there are impacted systems that we have not attained these goals yet. So we'll take a look at that if we get there. Then, of course, prohibit the discharge of toxic pollutants in toxic amounts. Dose makes the poison. We don't like any lead or mercury in our environment, but if we have no way to measure it below some level, we can't regulate below some level, right? So there is some aspect there about, okay, what are the limits of our technology? And if we do, let's say, take something more like benzene, but we discharge it in such a small amount that it's just essentially can't be toxic to anything, and some bacteria will consume it eventually, or it will oxidize in the environment. No big deal. But in toxic amounts is a problem. Okay. Some more stuff here that kind of developing the maximum permit term is 5 years. That's for simple permits. That would be like a permit for a swimming pool operator that has to drain their pool once a year, and they dechlorinate and drain the pool. Right? It's a few million gallons per day in one day of the year. So it's kind of a weird permit to deal with, but something like that, simple case, 5 years. If it's a large permit, they typically do it every year. So 5 years is just the absolute maximum. Kind of gives the states the authority, all of these things, significant penalties for permit violations, including you can revoke a permit for cause. There was this consent decree in 1976 that established more of a list of priority toxic pollutants. Those were essentially by industry. So they identified 21 industries that had specific pollutants known that they would often discharge, so they categorized those and put them. We have, in here, there is a table that kind of explains or shows some of that. I think we'll pass it in a moment. Okay, some more stuff. Pre-treatment things, talking about if you have a industrial wastewater and they're sending something nasty and they send it down the sewer system, that could cause problems for your municipal wastewater treatment plant. So there was a industrial pre-treatment program saying, okay, well, you can't poison all the bacteria that are trying to eat all the other garbage, right? That's not going to work for anybody. So you have to pre-treat, it as required. Stormwater and stormwater permitting. So just a little bit, and I know we're about to end here, but about the permitting framework here. So the NPDES system has jurisdiction over all point discharges anytime people are discharging pollutants into waters of the U.S. So waters of the U.S. is not just interstate waters, that's any body of water or any wetland that's next to a body of water counts as that body of water. Really the only exceptions are things like a wastewater stabilization lagoon. We make a lagoon, we're designing it for wastewater. We're not treating that as a water of the U.S., obviously. Agricultural irrigation ditches is another one we've exempted from that. Okay, so if any of those are true, you have to get that permit. It talks about what is a permit, kind of like a license to discharge. There's a few more interesting things. We talked about the classes of pollutants. There's some Supreme Court stuff. What is the waters of the U.S.? Talked about that. So we'll end with this. The Cuyahoga River Revisited. And this is, I think, this other article here. It's probably where I got it from. Or just has a little more meat to it. So that's posted, but let me just read this real quick for you. The first time Gene Roberts fell into the Cuyahoga River in 1963, he worried he might die. Mr. Roberts smelled so bad that his friends ran to stay upwind of him. Recently, Mr. Roberts returned to the river carrying his fly fishing rod. In 20 minutes, he caught 6 smallmouth bass. It's a miracle, he said. 58, the river has come back to life. Today, the Cuyahoga is home to more than 60 species of fish, said Jim White, executive director of the organization there. Doing a lot of cleanup efforts. Beavers, blue herons, and bald eagles are nesting along the river's banks. So, and that was in 2009. So, sort of a positive note. These programs and regulations certainly helped smallmouth bass are notoriously picky for their environment, so it's typically will not hang around if there's not a lot of dissolved oxygen, not pretty clean water. So good news there, right? It actually does work, and today we don't often have rivers catching on fire. So as much doom and gloom as that our current economy of attention will sell to you, there are some good things out there. So okay, we'll leave it there, and we'll do some activated sludge next week.